I'm on a whole new
Hey guys, and today I'm going to talk to you about weathering, erosion, and deposition. Now, before we begin, we have to give you a definition of what each of these processes stand for. Weathering refers to the breakdown of rocks into smaller pieces called sediments. Erosion refers to the process when the sediments are transported by wind, gravity, glaciers, man, and running water. And deposition is the process whereby these sediments are released by their transporting agents. They're dropped. Now, some key words that you need to pay attention to when you hear these three terms. For weathering, you need to think of the word break down, because literally weathering causes rocks to break down. When you hear the word erosion, the key word here is transport. Erosion is responsible for the transport of these sediments. And lastly, the word deposition refers to when the sediments are released, or in this case, dropped, which is the key word for deposition. Now, there are two primary types of weathering. Those two types are chemical and physical, or if you want to call it mechanical weathering. Now, mechanical weathering refers to the breakdown of rocks and minerals into smaller pieces without a change in chemical composition. These rocks maintain the same consistency and they look the same, but they're just broken down by some type of physical force. So when you think of mechanical weathering, you want to think of physical force. Certain examples would include roots or plant wedging action. As you can see in the illustration provided, you see plants growing through the cracks of the rocks, which would form smaller pieces of the rocks. In the case with ice frost or ice wedging, you have water that seeps down into the cracks of the rocks, and as the water freezes, that water expands, forming these hard patches of ice that break the rocks into smaller pieces. Now, exfoliation and abrasion are also types of physical weathering, and we'll talk about those in a minute. Now, there are three types of chemical weathering, and they include oxidation, hydration, and carbonation. Now, chemical weathering itself refers to the breakdown of rocks and minerals into smaller pieces by chemical change. Now, the key word for chemical weathering is that there is a chemical change. And what that means is that the rocks no longer maintain the same identity that they had before the chemical change. So there are three examples of this that I have provided. One is oxidation, the other is hydration, and the third is carbonation. Oxidation can be classified in all types of forms that you may have seen around you. It happens when oxygen combines with the element iron, in this case, in rock and reacts. This forms a new material called rust. A notable example would be in the case of the rust that forms on iron metal bars. Or if you have an old bike chain, anytime you accumulate rust, that is a form of oxidation. Another example would be in the case with the Statue of Liberty. If you didn't know, the Statue of Liberty is actually made of copper metal. But over time, exposure turned this copper color, which is normally brown like pennies, into a green color, which is now called copper oxide. Hydration, the second example, occurs when water dissolves the earth materials in certain rocks. This can happen in many cases to form worn down rock structures. And the last example is carbonation. This happens when carbon dioxide mixes with water to form carbonic acid. this can be seen in acid rain as well. And this chemically weathers rocks, breaking them down into a different form. Other acids that are also combined with the water to make acid rain. Now, weathering. I'm going to provide you examples of mechanical weathering and chemical weathering. Now, mechanical or physical weathering has several examples. One would be that of burrowing animals. As they dig into the ground, they tend to break rock into smaller pieces. Ice wedging, which I've discussed earlier, where you have water that fills in the pockets or crevices of the rock, freeze, and then break the rocks into smaller pieces. Then you have plant roots that grow through the rocks, forming smaller pieces, and you have landslides that can cause rocks to fall into little pieces based off of gravity. Now, the other one you have is abrasion, and that's when the rocks or other types of materials use force to break down the rock. In this case, you would have a rock carried by wind to hit another rock to break it, and that process describes abrasion. Now, chemical weathering has examples which include water, oxygen, carbonic acid, acid rain, plant acid. With chemical weathering, as I mentioned, there is a chemical change. In that case, you have things like water, which can cause hydration. You have oxygen, which can cause oxidation. You have carbonic acid, which can form caves or break down other types of rocks into smaller rock forms. You have acid rain, and you have the plant acids, the acids that generate from the plains that can actually break down the rock. Now, the rate of weathering is controlled by two factors. They are responsible for determining the rate. Number one is climate, and number two is the type of rock. For climate, in warm areas, you find that faster chemical weathering occurs. However, in colder areas, faster mechanical weathering occurs. And in wet areas, both chemical and mechanical weathering occur in fast rates. For the type of rock, a hard rock results in a slow weathering, which makes sense because those rocks are very durable and strong and can withstand inclement, harsh conditions. With softer, more whole-field or permeable rocks, you tend to have faster weathering because you have all types of things that can seep within those holes and break them into smaller pieces, or just break the soft material down into smaller pieces in the same fashion. Now, for examples of weathering rock, we look to a notable example of Mount Rushmore. When you look at Mount Rushmore, this shows a classical example of mechanical weathering. Mechanical weathering refers to force or physical force. And in this case, mankind was the physical force. There were specific people who were sculptors that shaped the design of Mount Rushmore. Now, if you look on the other image, you see the bottom part of the rock where you have weathered rock, and it is slowly being eroded. Now, luckily, we have specific people that update and fix the Mount Rushmore figures. But near the bottom, you can see how the rocks have been weathered and eroded and started breaking down. Now, after weathering occurs, you tend to see a process called erosion. Now, as I highlighted, the key word with erosion is transport. And with erosion, it carries the materials to some other kind of location. Weathering has to happen before the erosion. The rocks have to be broken into smaller sediments before they can be eroded. And now there are classic examples of erosion, which would be wind erosion or glacier erosion, and we'll talk about those in a little bit more detail. Now, the 5 main agents of erosion are running water, glaciers, wind, gravity, and man. Now, there are two major causes of erosion. From that list, those are wind and water. Those are the two major causes of erosion. Here is an example of how wind erosion can affect the U.S. As you can see from the map, the red area represents areas that feature high amounts of wind erosion. If you notice in the Midwest regions near Texas and Oklahoma, you notice a high volume of red color. You also notice the same coloration near the eastern coast of the United States. Now, when you think of wind erosion, you need to think of the ability to transfer small sediments from one area to another area. And a classic example can be shown when you think of desert lands, when you have wind blowing sands all across the desert. In other examples, they can be used to transfer other pieces of rock from one material to another. And these are additional examples. Now, in the case of water, water has the ability to form streams and ponds that are able to transport small sediments of rock or plants or shrubbery anywhere from one location to another. And that's another example. So again, those are the two major causes, wind and water. Now, our last step on the weathering, erosion, deposition is that of deposition. In deposition, the key word there is dropped, and it is the process where sediments are released and dropped by their agent of erosion. Deposition occurs after erosion. Most deposition happens in standing still bodies of water, such as oceans or lakes. Deposition is caused by the slowing down or loss of kinetic energy of the agent of erosion. And so deposition only occurs after erosion has stopped. Now, let's talk about erosion and deposition and how they work together to form land masses and further on. Now, with running water, we want to know, how does it erode? Now, as I mentioned, water has the ability to drag rocks along in the water. This can move the rocks downstreams. Now, the bumping of rocks widens and deepens the waterways, and that makes it faster. That makes it wider and able to carry more sediments. And so how does it deposit if it's moving? Well, when water slows down, some of the rocks are dumped off to the side, or in this case, deposited, as in deposition. They also can form deltas, fans, or plains. Now, another example of erosion and deposition in action happens with glaciers. With glaciers, how do they erode? They move massive ice. They're a moving mass of ice. Along the way, they tend to pick up and drag rock and grind across other rocks. This collects other material. This digs into the land and widens valleys just like water does. And eventually, the rocks are dumped as the glaciers melt. Again, you see an example of how the glaciers are depositing the rocks as they melt, and this makes moraines and drumlins. Now, here are examples of glaciers, and glaciers are nothing short of just frozen ice. Now, in another case with erosion and deposition with waves, waves can erode things by crashing waves, chipping away at rock substances. This also causes abrasion forms, and this abrasion leads to cliff formation, arches, and in caves. Now, how does it deposit? It carries particles from one location to the shores where they are deposited. And so that covers that process of how erosion and deposition are affected by waves. And here you can see examples of how a sand bank can be formed where water has collected tiny particles over time, and as they're washed onto shore, they deposit. So erosion and deposition especially work together in this process, and they can form all types of sand islands or sandbars, so to speak, and in some cases they can form sea cliffs and stacks. And so that completes our presentation on weathering, erosion, and deposition. I hope that I've shed new light on the understanding of weathering, erosion, and deposition, or as I like to call it, the WED system. If you have questions, please feel free to ask.